Welcome to qnawire.
Our question says to look at figure 9-67, which shows block 1, which I write has a mass of M1, which is equal to 2 times the mass of block 2. And these are sliding on a frictionless ramp, which has a height of 2.50 meters. And block 1 collides with block 2. After the collision, block 2 slides into a region where the coefficient of kinetic friction, μk, is equal to 0.500 and comes to a stop at a distance d within the region. What is the value of the distance d if the collision is both treated as A, elastic, and B, completely inelastic? So we're going to use the equation for the value of calculating V2 if this is, first for part A, considered to be an elastic collision, right? Yep, okay. So this is going to be equal to 2 times M1 divided by M1 plus M2. Okay, well, plug in and then that ratio is multiplied by the initial value of block 1. So this is equal to 2 times M1 divided by 3 times M1 times V1I, right? Which is equal to 2/3, and then we're going to plug in the value of V based upon it being due to gravity, which is the square root of 2 times G times H, the height. Okay. Well, now we can use conservation of energy, which is 1/2 M2 V2 squared is equal to all the energy that's lost to heat, which is the force of the heat loss from the friction, so F sub k, times the distance, which is what we're asked to find, which is equal to mu k times M2 times gravity times the distance. Okay, so M2's cancel. Solve for D. D is equal to 1/2 V2 squared divided by V2 divided by mu k times gravity. Well, we just solved for V2, so we can plug in the value for V2. So 2/3 squared is 4/9. Okay, well, 4/9 times 1/2 is 2/9. So we're going to have 2/9. And then root 2GH is going to be 2GH if we square that, okay, divided by mu k times G. Gravity cancels. Plug in the values for everything else in that expression that we had, and this comes out to be 2.22 meters. Okay, well, now let's treat it inelastically. So V2 is what's going to change here. It's going to be equal to M1 divided by M1 plus M2 times V1I. So this is going to be equal to 1/3 times root 2GH. So now if we plug 1/3 into that expression, so this is going to be D is equal to, if you look back over here, it was 1/2 V squared over mu sub k times G. So now if we square V, that's going to be 1/9. So 1/9 times 1/2 is 1/18. 2GH over mu sub k G. Once again, the G's cancel. Plug in the value of H into this expression, and it's 1/4 that of the one we just found, so it's 0.556 meters for part B. We can box that in as our solution.